What's up everybody, this is teacher Mulu. Today we are gonna solve the question that was shown up at the intro. This question challenges many students, so we will break it down today in this tutorial. Before I proceed to the tutorial, is there anybody who can remind me what the question is? Yeah, nobody is responding to my request because I have no enough like, share, subscribe. So please like, share, subscribe my YouTube channel to get every tutorial that I post. Da-da-da. Let's get started. So, as I have told you at the beginning of this tutorial, first let me give you the definitions of a polynomial function before I proceed to answer the question. Here is the definitions of a polynomial function. Let an, an minus 1, a1, a0, if these are an element of a real number, and let n be a negative integer. In other way, if this n represents the whole number, so the function f of x equals to an x to the power of n plus an minus 1 x to the power of n minus 1 plus a1 x to the power of 1 plus a0 is a polynomial function if and only if x must be an element of a real number and n must be the whole number or the negative integer. If x is an element of real number and n is an element of whole number, so this is called a polynomial function in variables of x. In variables of x. The first definition is in the variables of x. Degree is n. And let me give you another definition of polynomial function. Here is the second definition of a polynomial function. Let n, n minus 1, a1, a0 be a real number, and let n be a negative integer, then the function f of y equals to an y to the power of n plus n minus 1 y to the power of n minus 1 plus plus a1 y to the power of 1 plus a0 is a polynomial function in variables of y degree n. The first definition was it was a polynomial function in the variables of x in degree n. The second definition, or this definition, is the function or a polynomial function in variables of y degree n. This is in variables of y degree n, but the first slide is the polynomial function in variables of x degree n. So the only difference here is x and y. In the first slide, x is the variable. In the second slide, y is the variable. So please special attention should be given which symbol is in the bracket of f. If it is x, x is a variable. The rest are real number or constant numbers. If it is y, y is the variable, x is, or another symbols are an element of real number or constants. The only variable here is y. The only variable in the first slide is x. Let me give you the third definition of a polynomial function. All have the same character, but the only difference is in their variable. N is the same in those three definitions, but their variable is different. In the first one is x, in the second one is y, in the third one is z. So in this, f of z equals to n, then the power of n plus n minus 1, there is the power of n minus 1 a1, there is the power of 1 plus a1. Please replace this by n. Not z. Z is the variable here, not the power. N is the exponent or the power. So these are the three basic definitions of a polynomial function in different variables, the same degree. The first one is a polynomial function in variables of x. The second one is a polynomial function in variables of y. The third one is the polynomial function in variables of z. Look at this. The variable is x because this x, and this x are in the bracket of this is of x. In the bracket of this is the second one is y is the variable. Y is the variable. The third one is there is a variable. So after seeing of these definitions of polynomial functions, let us proceed to answer the question. F of x is equal to x to the power of yz is a polynomial or not? If f of x, if x comma y comma z represents an element of real number, first and foremost you have to select or you have to identify which variable, which symbol is the variable in this polynomial function. So in this the variable is x, because x, y, z are an element of real number. So in this function the variable is x. If the variable is x, the rest symbol represents what? An element of real number. They can be 1, 2, 3 or a lot of things. The only variable here is x. Y and z in this question is what? Constant numbers, or they are exponent or powers. So this is a polynomial function. This is a polynomial function in variables of x. So here is the answer. F of x equals to x to the power of yz is a polynomial function in variable x of degree yz. Variable x degree yz. So let us do second exercise that related to the second definition of polynomial function that I have shown you in the variables of y. If f of y equals to x to the power of, sorry, this must be x, this must be y to the power of x z. So it is a polynomial in variables of y, because y is in the brackets of this f. Degrees of x z, variable is y, degree is x. And let us do the second exercise that is related with the third definition that I have shown in the definition of a polynomial function. F of z equals to z to the power of x y is a polynomial function in variables of z of degree xy. So look carefully at these three exercises. The first one is the variable is x. The second one is the variable is y. The third one is the variable is z. But the rest they are just numbers. They represent 2, 3 or a lot of things. So when you select or when you identify a polynomial function from another function, first and foremost you have to look at the variable at the bracket of the function f. If it is x, x is a variable. If it is y, y is a variable. If it is z, z is a variable. The rest are numbers. It is sure they cannot be any negative integer, they cannot be fractions, they cannot be anything, but they must be represent a whole number or a non-negative integer. The product of y times z must be what? A non-negative integer. X is an element of real number.